Hi everyone. So let's see about some more functions available in this numerical Python NumPy library. So the first function we are going to see in this video are like a hstack and a vstack. So which is nothing but the short acronym for the horizontal stacking of your arrays or a matrix and a vertical stacking of your matrix or an array. So let's say you want to put one matrix besides another matrix. So in that case, you can use like a horizontal stacking of different two matrices. Or let's say you want to put one matrix above some other matrix, or you want to put some matrix below some other matrix. So in that case, you can use like a vertical stacking. To put those things into action, we need some matrix or some two-dimensional ND array. So let's first generate some array. I have already imported this NumPy library earlier. So NP, let's say we'll generate with some random module. So random dot, let's say random, and let's supply one tuple. So here the argument is like a size, and size is nothing but the tuples. So 3 cross 3 tuples I want to create it. 3 cross 3 size matrix I want to create. So that's why I have passed like a tuples. Let me assign it to matrix A, and the same way let's create another matrix, let's say B. Now as far as this stacking is concerned, besides one matrix to another matrix and above or below some other matrix, in that case the dimension has to be matched. Now here in this case, for the simplicity, I have just taken 3 cross 3. You can take even 3 cross 2 and 3 cross 2 also, and try horizontal stacking. Sometimes the horizontal stacking do not work, but the vertical stacking works based on the dimension matching. Let me just execute it, and let's just display A. So we have a 3 cross 3 matrix and another one is like a B. Now let's say we want to put this particular matrix besides here. So we'll have at the end the 3 rows, but instead of 3 columns, now we have a 6 column. So let's say hstack, and all those matrices you want to horizontally stack, you can just supply as a tuple. So A comma, let's say B. So both of the matrix, and now you can see the result. So 0.89 and 0.73 and 0.91. So this is what available here. Along with that, the first row of this matrix also got included. So 0.40, 0.092 and 0.32. So this is about the horizontal stacking. Now if you observe one thing in this horizontal stacking, the number of column in both of this matrix is immaterial, but the number of rows are important thing, because it has to be matched. So here also we have a 3 rows, and here also we have a 3 rows. Otherwise it cannot match it. Same way, let's say you want to put one matrix below other matrix. So we can use like a vertical stack. Same way we'll pass the argument like A and B as a tuples. So now if you observe the output, so this is our first matrix A. You can see 0.89 to 0.34, 0.73, and another matrix it has kept it like 0.40 to 0.26. You can even do reverse also. So let me copy it here. Instead of AB, let's pass B and A. So the first matrix it will keep it like a B, and below that it will put the another matrix A. Okay, so that is about the horizontal stacking and a vertical stacking of your matrix. And for the vertical stacking, if you have observed that the number of columns should match in both of the matrix. So this is not about just a 2 matrix. You can even put up more than 2 matrix also. So you can create another matrix and you can just stack it along with another 2 matrix. Okay, let's see some more functions. So we have already created this A. Okay, let me let me just multiply this A by 10. So we'll have all values got multiplied by 10. Now let's say you want to find the ceiling value of each value available in this matrix, or a floor values. So you can use like a floor and just simply pass A. So you can see every single value rounded to the floor value. So 8.97 got rounded to 8. Now floor is equivalent to the maximum integer which is less than this particular all values. So 7.33 which is rounded to 7. Same way you can use like a ceiling also. Now you can understand that why I have multiplied by 10, because in this case we'll get always all are 0 only, or it will be a 1 only if I do not do it. So that's why I just multiplied by 10. Okay, so here everything got rounded to the upper integer. So the minimum integer which is greater than any of these decimal values. So 8.97 got mapped to 9. So 7.33 got mapped to 8. Okay, let's see some more functions. So let me just assign this floor to some our new matrix. So in this case we'll have another matrix like a new matrix, and which is having all float value, but it is been truncated to any integer. Okay, let's say you want to find, let me first display this new matrix, the sum of every single value available in this matrix. So I can use like a sum and just simply pass new underscore mat. So every single value in this matrix got added. So 8 plus 7 plus 9 plus 7 plus 4 plus 1 plus 6 plus 8 plus 3 we have got. Now let's say instead of adding every single value in this matrix, you want to add row wise or you want to add a column wise. So you can use the same functions, new mat, and another argument you can pass it like a 0. So now you can see we got a 21, 19 and a 13. So if you just add at a column level, so 8 plus 7 plus 6 it will be a 21, 7 plus 4 plus 8 it will be a 19, and 9 plus 1 plus 3 it will be a 13. Let's say you want to add all those value, let's say you want to add all those value at a row level. So you can use the same one with axis argument 1. Now you can add all those values at a row level. So 8 plus 7 plus 9 it will be a 24. Now we have added this sum. Same way you can use the another statistical functions like let's say mean. So that is a mean. Now you want to get a mean at, let's say, column wise. So you can just simply pass axis is equal to 0. So it's a column wise mean value, and you want to pass the same thing as a row wise. So it's a row wise. So average of this 8, 7 and 9 will be 8. 1, 4 and 7 average will be 4. And 3, 8 and 6 will be a 5.66. You can even use the, let me create few more cell first. Let's say you want to find a cumulative sum. So you can use like cum sum. So you can just simply pass new underscore mat, and let me just execute it. Let me display the original matrix. So you can see it's like a 8, then 8 plus 7, then 8 plus 7 plus 9. So another function you can use like a cum products also there. So it's a cumulative product. So we got a very big number actually after multiplying all those 9 numbers. Okay, let's see some more functions. Let's say you want to find all those unique values available in our new underscore mat. So we have already this new underscore mat. So 8, 7, 7 is repeating. Then we have nothing, I guess 8 is also repeating. So let's find the unique. And we'll supply. So you can see we have just got 7 values because 8 is repeating 2 times and a 7 is also repeating 2 times. Now let's say you want to find the minimum value or a maximum value. So you can use like a min. So minimum value across full matrix is 1 only. But as I have told you, row wise minimum or a column wise minimum also you can find it. So every single column contains, here it's a 6 is minimum, then 4 is minimum, then there is a 1. Row wise minimum also you will get it. So here it's a 7, then 1, and then 3. Okay, same way you can do with the max also. So let me just copy it here. Let me check it. So 9 is the maximum value. If I just disable it, it's a column wise maximum value, and it's a row wise maximum value. Okay, now let's say you want to iterate over every single values available in a one-dimensional matrix. So let's just create one array. So we already learned a lot of methods to generate an array. So we'll use like a range, and let's say from 20 to 27. Yeah, some typo here. Oops. Let me display it. Now let's say you want to iterate over every single values available in this particular array. We can just simply use like a for loop. Let's keep the temporary variable like a item, and you want to iterate over this array. Let me print it this item. So you can see every single value it got iterated. Now along with the just value, we want to iterate over index also. So let me just copy this part, and instead of iterating over just array, we can use the enumerate function, and we can pass this array as a enumeration. Along with the item, we'll get the index also. Okay, and let me just print index also. So you can see the first index value is starting from 0, 1, 2, 3, 4, 5, 6, and from 20 to 26. Okay, so we have seen many functions in this particular video what we can apply on the top of this one-dimensional array or a two-dimensional array. So you can try out yourself. There are a number of other functions are available in this NumPy library. So that's all about this video. See you into next video.